This video is a quick guide to the newest SBS rail service offering. It is a Storm class reactor, now built on a standard SBS car frame. So let's get started. To enter, there's a control room here in the front. Like all the other SBS car frames, it comes with motor assist. To activate motor assist, click here. When this is tied into a HST, the Puma, it will broadcast on the appropriate channel. The default channel is 222. Instructions in order to drive the motors to assist in moving this along the rails. So the reactor. Let's turn off the internal lights here. We'll turn those on. We'll turn on the heat. In order to turn on the reactor, pretty simple. Flip the key. You can see in the menu that the rods will start to be inserted. Once the rods have begun to be inserted, we will get into a fast mode startup, wherein it will accelerate the temperature before it goes into stable mode, which will put in a lower temperature. At this point in time, it's now starting up the rods, starting to heat up the rods. And eventually it will start pumping water into the boiler, which will then power up the generator. In terms of generator power, you're looking at roughly about 6,100 watts of power it'll be able to generate when it gets up to full speed. Just take a quick look on the inside while that's powering up. There's two maintenance doors, one in the back. Well, there's two on either side. And here you have the boiler here is in the front. There's steam condensers. There's various flywheels for assisting in getting enough torque. The steam turbines, there are 5 steam turbines. They're all aligned along the length of the rail car. The generator is one large generator here in the back. In terms of the rods and the assembly, the nuclear pack are actually located here in the center of the train. And one of the things you'll notice here is there's a keypad on either side of the interior of the train. And the mechanics left their toolbox, and they've left something here, 8746. If you punch this in here, what will happen, and press enter, it will disengage the fuel pack, the nuclear package here in the center. This will drop out. And you can actually go through a process of replacing it. I haven't worked through all the details on how the replace works. I think that I may do that actually, but this whole entire assembly will drop out. I may show that later on. You can hear the reactor is now firing up. The reactor is active. This is for external radiation. We're noticing the fuel rod temperatures, core radiation level is increasing, and the various alerts you'll see here is that if there's a radiation alert, if there's external radiation, this will be generated. Joe's at 3 points of radiation. Well, this will generate an alert, as well as there are 2 sirens that are located in the back that will sound off. Lights will flash, and then you'll notice that there's some beacons will light up too as well. Right now there's some venting steam. Vent steam's at 9 bars of pressure. Typically you'll find is that the boiler will never get over typically 9. It'll start to settle down. What it's doing is it just kind of goes through the excess water and just kind of blows it out until it gets to kind of an equilibrium point. So you notice now that the fuel rod temperatures is now running in stable mode. These are the temperatures on the kind of rod groupings. Our boiler temperature is starting to rise. So it goes to a minimum of about 104 and then it starts going up and down, typically between 101 and about 120, and then it'll stabilize in that 117-18 range. Pressure is typically will stay at about 8.4. It'll just kind of go up and down as it kind of finds the sweet spot. Notice here in the bottom we have some information relating to the steam boiler. So they are all creating steam and torque, all of the various turbines. And we're noticing that our generation power is going up. We're now 6,000. It'll go up to around 6,100 is typically the max out level. Some other things that are here, if you get various alerts, you can silence the audible alerts, including the sirens, just by clicking this button. Shows the generation. This shows kind of the temperature of the steam condensers. There's 2 steam condensers, one on either side. This forced neutron purge, what it does is that if you press this button, it will automatically input the rods to 100% insertion. So it's just a way to kind of quickly, if you want to cut down on the radiation, then it's kind of, you can do that there. But most of it is automatic, so you don't have to do too much. Down here is various water levels. So you have your boiler water level, and then there's a reserve water tank. The reserve water tank is located just above the boiler, and it'll feed the boiler. If you find that you want to add more water to the boiler, typically you're not going to find that you're going to need to add hardly anything, but it's an option. Then you can press this button. It's on a toggle, and what it'll do is it'll transfer water from the reserve water into the boiler. When you want to transfer water out of the boiler, the only way you can do it is you can have to do it through the condensers. You press this here, what it'll do is it'll transfer water that's bound for the boiler, and it will direct it into the reserve tank. It's a slow reclamation because the amount of water that's being popped back by the steam is not a lot. So it takes a bit of time for it to kind of build up enough pressure, and then it will start filling the reserve water tank. So just watch for that. It takes a little bit of time in reclamation, and then it's a little bit that goes up at a time. It's not a heavy, so it's all dependent upon how much steam in the system, and it uses the steam reclamation in order to push it up. Yeah, I'll go up there eventually. We'll check back on that. So core radiation level, fuel rod temperatures, a summary if you want to take a look at it, control rod insertion values. At the top we have external radiation with the reading external radiation and a clock. The various alerts you have, core radiation, if it gets too high, this will start to flash. There's a warning and a critical level. For meltdown, there's a warning and a critical level. Overpressure is basically if this goes over 9, this will flash and a vent out the top. External radiation, this will again flash too as well if the external radiation gets past a certain level. Yeah, so you can see right now it's starting, it's a slowing. So let's just do, we'll put it back to normal, and there's not much you have to do there. So right now we're running at 6,100 roughly watts of power, and a common question I get from everybody is, how can I put this in meltdown? Well, on its own, basically, it's pretty safe. It's very difficult to do. But much like the Fenris, I've included a system that allows you to manually induce a disaster scenario. So much like the big red button on the Fenris, if you look up here in the ceiling, you push this, and what's going to happen, this will light up saying meltdown scenario is requested. What this does is the rods are no longer inserted to control it. We enter in a state wherein the reactor starts to go out of control in terms of building up heat. There's our meltdown warning that we've reached the warning level. I'm going to put this, toss that, grab my hazmat suit, and now it's going into warning. The boiler just exploded because I overpressured. And we have meltdown. And the reason we have an explosion is I added a system wherein there's a multiple warheads located inside the nuclear package. And if meltdown is achieved, the warheads will explode. So we get lots of raids, lots of radiation, sirens going off, all the alerts going off, fire, disaster. Seems like everybody wants to induce some meltdown. So that's just been a quick introduction to the Storm class reactor mounted on rail. If you have any questions, post them in the Steam workshop along with the entry, and I'll see if I can answer them. Thank you.